Hello students, I hope you are good, well and fine, and today we will be continuing our discussion on the topic of relation functions, in which we are specifically discussing about functions. Okay, we till now what we discussed, we discussed a definition for function. We also discussed some functions and their graphs for such like real value function, identity function, constant function, polynomial and rational functions, the modulus and the signum function, the greatest integer function, and then we discuss the types of function which are 1 on 2. Okay, and then we will be further moving on the examples based on these functions, and then we finally will arrive to bijective function. So let's move to them now. First of all, before beginning, let me recall you. If you recall, in just a previous class, our function f from natural to natural, the function was defined like this. This was what? 1 1 1 1, but not on 2. Yes, whereas f from a real number set to real number, the fx, the same function, becomes 1 1 as well as on 2. Yes, so why this happens? Because of the, first of all, of the domain and the codomain we took. So to be 1 1 or on 2, the function is totally depending on the its domain and codomain set. Okay, so it might happen that one function is not 1 1 and on 2, but if you take another say set or a subset of those function or those sets given to you, it might become that it happens that it will be 1 1 as well as on 2. So the main point is to highlight over here is that the role of domain and codomain is very crucial in functions. Whenever you were asked any question related to function, please specify or get full information about its domain, codomain and range. Okay, all the terms, domain, codomain as well as the range term is must. Okay, so whenever you are facing a question related to function, please keep these terms or these things in mind. Okay, now let's start. So here our function is from natural number set to natural number set. The function is given by like this: f of 1 is equals to f of 2 is equals to f of 1 is equals to f of 2 is equals to 1, and f of x is equals to x minus 1 for every x greater than 2. Okay, domain and codomain both are my natural number set. Domain, so input is also domain and output is also, sorry, input is also natural number and output is also natural number. Okay, or you can say the input, and here you can say the output. Okay, not the actually output, but output will belongs to this set. Okay, now what? Now here we need to show that it is on 2 but not 1 1. So first of all, let's show not 1 1. Not 1 1. Not 1 1 means we have x1 not equals to x2, but f of x1 is equals to f of x2. This happens. So we can easily see from over here, 1 is not equals to 2, but f of 1 is equals to f of 2. So from this directly we can say that it is not 1 1. Yes, because in 1 1 the if two elements are distinct, then their image also distinct, but here the image is same. So that's why we are saying that it is not 1 1. So not 1 1 means this. Okay, I hope that it is clear to now. How we are going to show that it is on 2? Very clearly, to show it is on 2. Okay, to show a function is on 2 is same as to show the range set is equals to the codomain set. Okay, so how we are going to show that? Quite easy. Let's begin with this. So fx is equals to x minus 1 for every x greater than 2, and x belongs to what? The natural number set, but also satisfies this. This means x, here x can be what? 3, 4, 5 till infinity. Okay. Okay. Now, if you recall how we start with this, we first of all take fx is equals to y. Okay. Now, putting in place of fx, what you will get? Y is equals to x minus 1, and then always what we always do? We always try to find out x is equals to some expression of y, some expression of y. For example, if you manipulate this whole equation, what you will get like this. So here x is equals to some expression of y. Now you try to see what values you can put over here. So what values can you put over here? If you see what values you can put over here, you can easily see that you can put say what you can put, can you put 1 here? If you put 1, then x will be 1 plus 1 will be 2, but as you know, x belongs to this set. X must be greater than 2, strictly greater than 2, and belongs to the natural number set. This means x starts from 3, 4, 5 and so on. So you cannot put y equals to 2. So y cannot be 1 if y is 2. If you put y is 2, then if y is 2, so 2 plus 1 is 3. Yes. If y is 3, then it will be 4. Yes. Now you can put any y. So this is true only when y is greater than 1, because you can put 2, 3, 4 any natural number but not 1. Okay. So but in order to show that range is equals to codomain, and codomain, and we know codomain is my natural number set. Here we just find out that we are just getting one element not in the range set. So what happens? So nothing happens if you try to see carefully here. So another y is given over here. Yes, this is also what? The output. Yes, or we say the range set element. Yes, the output is what? The range set element. So from this I can also include, so from this, or from this definition, what I can say? I can say that y can take any natural number value but not 1. Okay, but from this alone, what I can say that y can also take one value only when if x is 1 and 2. because it is already defined over here. So y can also take one value. So this means in total the y values, the set for y values will be what? 1, 2 till infinity. So this means this is what my natural number set, and this is what the codomain set, and this is what the range set. Yes, or the output set. Yes, so this means this is onto. So we showed onto, we showed not 1 1. Okay, I hope that it is very clear to you. Let's move to next. Now here, show that the function f from R to R means real numbers to real numbers. This set is my domain and this set is my what? Codomain. Okay. Now fx is defined like this. Fx is equals to x square. If you can quickly answer, if you recall the what? The diagram for it, you know from the horizontal test, it is not 1 1, but we need to write a proof for it. Okay, so but we know that it is not 1 1. Okay, it is not 1 1, not 1 1. Okay, so how we are going to show? It is quite easy. First of all, start with what? Fx1 is equals to we can say not 1 1 means not 1 1 means x1 not equals to x2, but fx1 is equals to fx2. Yes, so can you find such x1 and x2? So not 1 1 means there are x1 and x2 such that x1 and x2 are not equal, but this is equal. Okay, let's see. So if you say that x1 is equals to 2 and x2 is equals to minus 2, then what will be your fx1 which is 2 and fx2 which is minus 2? The answer for this is 2 square, and the answer for this will be minus 2 square, and the output will be 4 and 4 equal. So we showed that it is not 1 1. Why? Because we have two input and both of the inputs are distinct to each other, but their image or the output is equals to each other. So this means not 1 1. Okay, I hope that it is very clear to you, as you can see from this picture also. Now what about the onto? It is quite clear. Not onto means what? Let me write it. First of all, let me clear the board. Okay, so not onto is quite easy if you can do it by yourself. So not onto means there exists a y from codomain set. There exists y belongs to the codomain set such that y cannot be equals to f of x for any x belongs to domain. Here domain is my what? Real numbers. Here codomain is my what? The real number set. Okay, can you find it? Yes, indeed. So take y as any negative number, say minus 1. So can minus 1 be equals to x square? Can minus 1 equals to x square? Or let me write it like this, fx which is x square. Can this be written? No, because if you take any real number, if first of all it is not possible, because if you take square of any real number, what you will get? You will always get positive answer. Okay, you will always get, or say, non-negative output. But here we are asking to get a negative output. This cannot happen. That's why it is not possible. So this means that we have found that such y in the codomain set which is -1, such that y is not or y cannot be written as y cannot be written as fx for any x in the domain, as you can see. Or pictorially you also can see that if codomain is R, as you can see, the range set, you can also see the range set is from this element to this infinity. So the range set is equals to what? 0 to plus infinity. Yes, but the codomain set is R. So codomain set is not equals to the range set. So this means not onto. The another way to look is this. Okay, I hope that it is clear to you. Now let's move to next example. So what it says, not actually, it says we have to show that onto function we are given, first of all we are given a function and that function is onto, and onto function from the domain elements are 1 2 3. These are my domain elements, and these are my codomain elements, codomain elements. So codomain elements are these. Okay, first of all, it is a function, so I need to satisfy all the function condition. Okay, so first of all, let us just read the question. So that that an onto function from this set to this is always 1 1. So we need to show that it is 1 1. Okay, we will show by pictorially. Okay, so this is my domain and this is my codomain set. Okay, elements are listed respectively. Now first of all, this is a legit valid function. To be a legit valid function, what we need that every element in the domain must be associated or must have one and only one image. So this means yes, this can happen, this can happen, this can happen. But if you see that it is given that it is onto, it is what? Onto. So this means that no element in the codomain set must be alone. If you see here, 2 and 3 are alone. Yes, so we need to make something. So what we can do so that they cannot be alone? So it is quite easy. If you see that what you can do is this, you can associate this, this or this. Yes, you can do it. Yes, of course we can do like this, or 1 2 3 1 2 3, and I can also do like this. Yes, or can you think another way? Yes, other way. So 1 2 3 1 2 3, one can go where? One can go here also. Okay, so there are further ways, but we are not going to do or list all of the ways. But in every ways, because this thing is very crucial over here, that the function is given to us is onto. So onto function, this means that every element over here must be associated or must have some pre-image. Okay, so must have some pre-image. So you draw any diagram, you will end up with what? 1 1, as you can see over here, as you can see over here, as you can see over here. Every element in the domain set has only one and only one image, and every codomain set, every element in the codomain set has a pre-image. Okay, so we know that range is equals to codomain. Yes, range is equals to codomain, and we know codomain is equals to, if you see, codomain is equals to the domain set. Codomain is equals to the domain set. Okay, so there from this what we can say that fx1 is equals to fx2, then this will imply fx1 is equals to fx2. If this doesn't happen, if you are saying that x1 is not equals to x2, if you are saying this, what this means, if x1 is not equals to x2, then what, fx1 is equals to fx2. This cannot happen, because if this happens, this means two different elements we are talking about, let's say x1 and x2, the x3 elements. So we have in total 3 elements, as you know. Yes, 1 2 3. So I am saying 1 as x1, 2 as x2, and 3 as x3. If take any x1 and x2 element which goes to same element, and this remaining element will be just associated to only one element, because it is a function, it cannot be like this. Yes, so this means, what this means, this means that it cannot be onto, because if this condition happens, this means two different inputs are associated with single output, and then we in total we have 3 input, and this single input will be associated to just single output. Then we in total, if you see, we will be getting 2 elements in the range set, but there are 3 elements in the codomain set. Then range cannot be equal to the codomain if this happens. So from this what we can say, that it must have to be 1 1. I hope that it is clear to you. Okay, let's move to next. Now show that if this function given to us from this set to this set is 1 1, then it must be onto. In previous we saw, if it is given onto, then it will be 1 1. If now question says that if we are given that the same previous function is 1 1, then we need to show that it is onto. Quite easy. So 1 2 3, 1 2 3. If it is 1 1, this means x1 not equals to x2, imply fx1 not equals to fx2. For every x1, for every x1 and x2 we take from the domain set. Okay, so if this happens, that means we cannot associate any 2 different elements to the same image. This means 1 is associated to 1. Now 2 cannot be associated to 1. So the only possibilities are these. So just associate it like this. Okay. Now what? Now 3 cannot be associated to 3 and 1, because they are already occupied by these elements. Okay. Now the only remaining possibility is this. Okay. So this is one of the way to define our function. So here you can easily see that now codomain set and the range set is equal to each other. So range is equals to codomain to prove the onto. Okay. So okay. So because it is 1 1, this means x1 is related to some element. I am saying that this is my x1, this is my x2, this is my x3, and I am saying this as my y1, y2, y3. Codomain set, if you see, codomain set is y1, y2, y3. Yes. Now to show that range set is also equals to the codomain. This means range is also equals to y1, y2 and y3. Okay, so if x1 is related to what? Is related to fx1, yes, and then this element I am saying what I am saying it as y1. Okay, so pictorially let me draw over here. So we have three elements, one x1, x2, x3, and x1 can be 1 2 3, x2 also can be 1 2 3, x3 can be 1 2 3. Okay, but but all of these elements must be different to each other. Okay, distinct elements. Okay, then x1 must be associated with what element? fx1. Yes, because they are onto because they are 1 1, then x2 must be associated to x2, x3 must be associated to ff x3, and we know x1, x2, x3, x2, x3 not equals to each other. This happens. And okay, so if this is 1, then this might be 2 or 3. If this is 3, then it will be 2. If this is 2, then this might be 1, this might be 3, and so on. You can make arrangements. Okay, now what? Now this, as this is associated from this, what you can say that f of x1 is not equals to f of x2, which is not equals to f of x3. Yes, all are different. So this means then this is, and I know what? I know that f of x1, f of x2, f of x3 belongs to what? Codomain set. Codomain set. And in codomain set, if you recall, what you have? y1, y2, y3, and we know y1 not equal to y2, not equal to y3. So this means, because these are all different elements, these are also all different elements, this means f of x1 can be either one of them. And if say f of x1 is say y2, then this means f of x2 can be y1 or y1 or y3. Let's just say y3, then it will be y1. So from here we can say that range set is this. Okay, so we can easily say that range set is my equals to the codomain set. I hope that it is clear to you, as well as from the pictorial representation as well as from the statements. Okay, let's move to next. Now, the what we just saw, the remark is the result mentioned in the examples are also true for an arbitrary finite set x if my function f from x to itself x, okay, is given 1 1, is 1 1, then it will be onto. Okay, then it will be necessarily onto. If it is given onto, then it will be necessarily 1 1. Only if we are given that x is what? X is my finite set. We are only talking about the finite set. But if you talk about the infinite set, this thing might not be true. Okay, for example, if you see, if you take infinite set such as n is infinite set, as you can see, it goes forever. So if my domain is 1 2 3 4 till so on, and here are my codomain set is same 1 2 3 4 5 and so on, and if I associated 1 to 2, 2 to 3, 3 to 4 and so on, you can see that it will be 1 1 function, as you can see. Yes, it will be 1 1 1 1, but as you can see that 1 is not associated to any element, or it has no pre-image in the domain set. So this means this is not onto. So not onto. So that's the main difference here, that x to be finite and x to be infinite. Okay, I hope that it is clear to you. Let's move to next. The final type is my bijective function. So the bijective function, a function f from x to y, is said to be bijective only if it is 1 1 as well as onto. So if my function is 1 1 as well as onto, then it will be what? Bijective. As you recall, if you define function f to x, where f is from R to R, the set of real numbers to the set of real numbers. So this is my indeed, if you see pictorially, you will get that it is indeed my what? 1 1 and onto. Okay, and we already showed. Okay, so this is bijective function. Sorry, so it is what? Bijective function. Okay, I hope that's very clear to you. So that's it for today. Thank you.